Okay, so this is the stock system. Stock nomenclature is a different way of handling ionic compounds that are made with elements that form multiple ions. So your transition metals, you know already, they can form multiple ions. You can have iron with a +2 charge, iron with a +3 charge, copper with a +1 charge, copper with a +2 charge. Those will form different compounds because, thinking back to your binary ionics, what informs the subscripts? It's the ratio of the charges. It's what balances. So when those charges balance, the subscripts are going to change. We already talked briefly about the fact that with these types of cations, they are named for the charge. So the iron 2 plus is called iron 2. Ooh, not revolutionary at all. Iron 3 plus is named iron 3. And that Roman numeral is essential. It tells you what the charge on the cation is. You cannot just say it's an iron cation. You have to specify iron 2 or iron 3. There are a few metals that only form a single cation. Those you don't have to do the designation of charge. You don't have to put a Roman numeral with those. Everything else gets a Roman numeral. So what this means is that if you are given the following, iron 3 oxide, and you have to write a name for it, or you have to write a formula for it rather. Same as you did with binary ionics, you're going to write the ion. So iron 3 is Fe what? 3 plus. Oxide ion is O 2 minus. Same exact crisscross. Fe room for a subscript, O room for a subscript. Take the magnitude of the charges and crisscross them, and you get Fe2O3. Okay, that's pretty easy. Writing the formulas for these is not hard at all. That's the easy part with these. I would say that with binary ionics, both parts are equally straightforward. With these, writing the formulas from the names is much more straightforward. Let's do one more for practice. Looking at that table of common metallic cations, pick your favorite. Let's do chromium 1. Chromium, you probably know best from actual chrome. Chrome is a thin plating of chromium alloyed with another metal on top of a metal, so you'll see it on cars and motorcycles and bicycles. If we have chromium 1 partnered with, sure, oxygen. So chromium 1 oxide. Same thing. You're writing the ions that are present. Chromium 1 is Cr1 plus. Oxide ion is O2 minus. We crisscross to get our charges, our subscripts rather. And we simplify, we don't keep ones. So we get Cr2O. Where do people screw this up? This is the gift that a lot of years of teaching a content area will give you. Where people screw this up is they look at that formula and they say, oh, it's chromium 2. No, it's not. Those subscripts are not the charge. Okay, so let's then look at going the other direction. When given a formula, how do you find the name? Well, wait, let's do one more formula from name before we flip, because I want to do this one. Copper 2 oxide. What's the charge on copper 2? Hold up fingers. Yeah, ridiculous, I know. Cu2 plus. What's the charge on oxide ions? 2 minus. We do our little crisscross, Cu, room for a subscript, O, room for a subscript. We get 2 and 2. Is that our formula? Are we done? We have to simplify. So that's going to be CuO. Okay? That will be CuO. Because we can simplify that. That 2 to 2 is the same as a 1 to 1 ratio. There was one question on the 5th quiz that a lot of people missed. The arsenic question. What was it? Aluminum arsenide? Yeah, that's Al3AS3. That simplifies to AlAs. Huh, who knew? You've got to simplify those ratios. It's a ratio, so you look for the simplest form of that ratio. Okay, questions on writing name formulas when given names on stock compounds. Okay, given a formula, can you write the name? Well, the answer is probably yes. So let's look at Fe2O3. I think we did this one already, but that's okay. When you're given a formula that includes what you know is a transition metal, and most of the transition metals can form multiple cations, if you tell me that's iron oxide, I'm going to mark it wrong. Because the different iron oxide compounds have different characteristics, they have different colors, they're different materials. So you can't just say it's iron oxide. What you have to do with these is what I call the reverse crisscross. So you're going back to figure out, you know that iron had a positive charge, and you know that oxygen had a negative charge. If we reverse crisscross these, we can see what the charge on the ion was. So which iron oxide is this? Whoops. That's iron 3 oxide. The most common mistake people make is taking this subscript and calling that iron 2, because they see that 2 and it confuses them. You have to reverse crisscross. So you need to go back and figure out what the charges were that would have gotten you that ratio. Let's do another one. Okay, so I've got SnCl4. Sn is tin, tin SNPs. Tin SNPs. So I'm going to leave myself space up here. I know that tin is a metal. It would have had a positive ion. I know that chloride is a halogen. It would have had a negative ion. I'm going to reverse crisscross. So this 4 would be there. There's no subscript on tin. So what does that mean? 1. No subscript is an understood 1. Now, does chloride usually have a negative 1 charge? Yeah. That's consistent with what you know. So is there a tin 4? You can look at that chart. Yeah, there is. So this would have been tin 4 chloride. Good? Questions? Let's do one that's a little harder. Okay, PbO. PB, I don't want any lead in my peanut butter sandwich. PB is lead. I have all kinds of mnemonics. If you make some up, tell me, because I will repeat them for years. So PbO, I'm going to do the same thing. I'm going to reverse crisscross these. Up here, I'm going to write my ions. I know that lead is a metal. It's going to have a positive cation. It's going to have a cation. It's going to be a positive ion. Oxygen, I know, forms a negative ion, an anion. What are my subscripts here? 1. Oops. Is that right? Anybody have an issue with that? I got an issue with that. I got a big old issue with that. Does the oxide ion typically have a negative 1 charge? No. What does it typically have? Negative 2. Yeah, 2 minus. So what had to have happened here? If we multiply this by 2, we get the correct charge on oxygen. What do we have to do to this then? Multiply by 2. This is actually lead 2 oxide. Okay? Because it's simplified. When you do that reverse crisscross and you see one that doesn't fit, that's where you go, oh, wait a second. Hold on, hold on, hold on. Let's do one that's even, I think, even tougher. Let's do NiO2. Ni is nickel. So I know that this is, and I sometimes will do this. I'll write nickel something oxide, because that gets the first piece out of the way. I know this is, nickel something oxide. I don't know which one. I got to figure that out. So I'm going to take this to here. I know that nickel is a transition metal. It's going to form a positive ion. Oxide is always a negative ion. I'm going to reverse these. Okay, is this right? Am I done? Is this nickel 2 oxide? Does oxygen typically form a -1 ion? No. So I know that I have to multiply that by 2 to get the common anion of oxygen. I'm going to have to multiply that by 2 as well. This is actually nickel 4 oxide. Questions? 9? Okay. All right, so go ahead and work on the practice. When you feel like you're ready, when you've checked all your answers, you can go ahead and take the FIP quiz. Chunk 3 is posted. We'll probably, depending on where people are with the FIP quiz, we may start chunk 3 together tomorrow. We'll see where we're at.